having an enriched experience so far, gaining valuable insights from our expert speakers. Today, we have yet another informative session lined up for you. It is my pleasure to introduce our esteemed speaker for today, Mr. K. Anil Kumar. He is currently working as an assistant professor in the Department of Computer Science and Engineering, Data Science at KMIT, Hyderabad. With an impressive 5 years of industry experience working with IoT devices, microprocessors, and programmable logic devices, along with 14 years of teaching experience, Mr. Anil Kumar brings a wealth knowledge to the field. He has published research papers in reputed international journals and has successfully undertaken several projects in diverse domains. His academic excellence is reflected in his achievements as an NPTEL topper in IoT, Python for data science, and microprocessors. His research interests lie in IoT, artificial intelligence, and cloud computing, making his expertise highly relevant to today's rapidly evolving technological landscape. Today, he will be delivering a session on service discovery in IoT, a crucial topic that plays a significant role in enabling seamless communication and interoperability among IoT devices. This session will provide key insights into how IoT services are efficiently discovered and managed, enhancing the overall functionality of smart systems. Please join me in welcoming Mr. K. Anil Kumar sir, who will be guiding us through today's session with his valuable insights.
Yeah, good evening all. Thank you, Nidhi Madam, for the introduction. Let me start the session. Today's topic is service discovery in IoT. Now, what do you mean by service discovery in IoT? Yeah, we have been using this one in daily life. The technical term I'm saying is service discovery, as we all are doing these things in the daily life. Let us see an example. Let us take a scenario where a student want to access a web page. Now he is typing HTTPS, a protocol of application layer, to search the web page of our college. For this, get this web page for him, he require first is a Ethernet cable or a Wi-Fi router. Ethernet cable should be given to the router. Now these should be configured, right? This should be configured using a IPv4 or IPv6 address. Right? Now, after this is IPv4, we should send data. Thus will go from the student. This will go to the network layer. First, when I connect to the Ethernet cable or router, it will be in the link layer. Then when we configure the IPv4 or IPv6, it become a these protocols IPv4 and v6 comes under a network layer. After this, to communicate data to the remote place, we will be using transport layer protocols using either TCP or UDP. At the end, the HTTP which comes is the application layer protocol. Now, everywhere we require service. If this is a scenario, everywhere we require a service. It's a link layer or a network layer or a transport layer or application layer. Everywhere we require a service. Now, to discuss all layer protocols, it will take a 3 to 4 hour session. So we'll discuss the important service discovery protocols today. Let us see first what is service discovery. Service discovery is a process by which IoT devices automatically find and connect with the other devices and service onto the network. Let us show me the, suppose I am using my laptop now. If I click on my laptop, there is a symbol called Wi-Fi symbol here. You can see here, as I share my complete screen, I'm connected to the KMIT LAN, KMIT audio, KMIT blocky. These are networks I connected. I can connect actually. So they all are have the service through Wi-Fi I'm getting now, right? Similarly, you can see what is service discovery now. Service discovery is the process by which IoT devices. So it can be any device, to be frank, generally, as we are dealing with IoT devices, it can be E32 or Arduino or Raspberry Pi. Automatically find and connect with other devices and services on the network. This process, what happens, automatically I'm connecting. So it eliminates the need for manual configuration. So once we connected to the network, there is no need of manual configuration, making system for more dynamic, and it makes the system more dynamic and scalable. Now, what do you mean by more dynamic and scalable? More dynamic means, suppose, I'll give example, just now only, we can let us see my Wi-Fi network. I'm seeing only 3 networks now, right? If I turn off the voice, if I turn off and turn on, I may get more than 2, 3, 4, right? So it is not manually again configuring those networks. So dynamic and scalable. We can increase the number of network devices or decrease. It's called scalable. Yeah. So you got difference now without need of manual configuration. Example, if I connect to the pen drive to the pen drive to the laptop, it automatically detects the pen drive and asks for the operation, the transfer data or copy data, right? So we are not doing anything manually configuration, making system more dynamic. So depending on the availability of the, if I take example of, again I will take the example now. See here, my network is there. Out of 3 networks, why connected to the, out of 3 networks, I am connected to the KMD LAN. Why? Because it has more strength and is more near to my laptop. If you see the 3 networks, KMD LAN connected as authentication is required. I have taken the credentials also. But if you observe there, it has more strength because it's very near to me. So dynamically it changes. If this is not there, automatically it will go to KMIT audio also. If this is not connected properly, so the issue is there here, it automatically connected to the KMIT audio also. So this is called dynamic. Now what is scalable? Scalable means in a home, let us say example, in a home, there are 3 or 4 IoT enabled devices are there, like a switch is there, a geyser is there, AC is there, and a light is there, and there is IR sensor is there. When a person enter into the hall, it automatically turn on the light by sensing the IR sensors. As this light is on, it indicates to the other sensor that he may go for a bath. Let us turn on the geyser automatically. So they are, if you want, that will automatically turned on. Scalable. So I may increase the number of devices to be in the network. I can reduce the number of devices in the network. It is called scalable. So service discovery is important in IoT. Yes or no? Yes. Why? Because first thing is it has dynamic network. Devices can come online and often dynamically. Dynamically means generally when you communicate in data to mobile phones, there will be a haddock network which is dynamically established. Haddock means it will be there for just for 10 minutes or 5 minutes as long as I transfer data. It's called dynamic networks. Example, if I want to pay the bill through a tab mechanism, it creates a temporary network, a dynamic network, which is becomes online available. When I pay the amount, it becomes automatically offline. So device will come online and offline dynamically. Autonomous operations. IoT devices should able to discover and interact with without human intervention. I give an example. These devices will communicate with each other and they make autonomous operations. Example, when a person enters, it auto detects the IR sensor is there. It detects the person and it communicates with the light, a lamp, turn on automatically. So Now IR sensor and the lamp are communicating without any human intervention. He is not manually touch on the device now. So when he comes into this, its area, the IR sensor automatically senses the presence of the human being and automatically turn on the lamp or a light. So this is called autonomous operation. Things will done automatically without any human intervention. Scalability, as I just now told you, we can grow or minimize the IoT devices without any manual configuration. We can call these are the characteristics of service discovery devices. What benefits we have? Let us see. The first benefit is scalability, which I discussed just now. Easily we can manage large number of devices. Efficiency. Devices can discover each other automatically as interoperability. Yeah. Interoperability means two devices will communicate on their own without human intervention. That can be two different manufacturers also. Example, Alexa device may communicate with the Chromecast device. Or Amazon Firefox may communicate with the Alexa device. Or the Chromecast device may communicate with the Alexa device. Or in my home, I'm using Alexa device and a Wipro smart bulb. They are used to communicate automatically. So this is called interoperability. Enables devices from different manufacturers to communicate. So example, the Alexa device and Wipro smart bulb will communicate even though they are of different manufacturers, they can able to communicate. It's called interoperability. They can operate without any human intervention. Flexibility. Device can be reconfigured based on the network changes. So the flexibility is there. I can reconfigure the devices as per our requirement, as per the changes there in the network. Now, what type of services we have in the service discovery? The first one is simple service discovery, where the device announces and search for services based on the predefined criteria. Here we may have to give the basic required things in SSD. Example, recently I bought a Amazon Fire Stick. So while giving to the TV, a smart TV, I should basically predefined criteria is there how to make establishment of or configure the device. Next one is dynamic service discovery. Here, device dynamically defines services as they join or leave the network. Example, the smart bulb which I buy with Pro or any other smart devices are there. They need to again configure from the scratch. Example, if you give a pen drive to the laptop, we are not again configuring manually. It will detect it automatically and we can transfer data without any intervention. So these are the two types of service discoveries. Now, how does service discovery work in IoT now? Let us see how this service discovery works in IoT, because whatever I have seen are just in daily life applications. Whatever we have seen is a daily life applications. So step one is service advertisement. The whichever device available in the network, it has to broadcast the services onto the network. It says that I'm available. Example, there are 4 devices available in the network now, or the data should be shown in my laptop. You can see here. So use my laptop, you can see I'm getting 3 or 4 networks. You can see here. Yeah, you can see at present I'm getting 2 networks. So they are broadcasting their services. These two are, now I got 3 networks, right? Now these are broadcasting their services. Now I can use any one of them depending on my requirement. Next, after that, this discovery query. Now my laptop will query. Devices send queries to the discover available services. Then after this, there will be a service selection. Out of these three, I'm selecting this one. Device select the best service based on the, you can see here, based on what? Based on specific criteria like signal strength and latency. What is signal strength? You can see my laptop now. I have connected to three networks. Out of this, KMIT underscore LAN has more strength. That is called signal strength. Now, what is my latency? Latency means here the speed of the network. Whatever network I'm using here, it may be 100 megabits per second or 1 gigabits per second. Suppose a device has good strength and good speed will be preferred always. Less latency time and more signal strength, they will be preferred always. So there is a specific criteria. Based on specific criteria, what is the signal strength? You can see the example, it has more strength now compared to the other two. And latency means at what the network as what speed it is. 100 megabits per second or 1 gigabits per second. The internet speed. Next one. So the three steps are already over now. Next we'll see service discovery protocols in IoT. So I explained you the protocols initially with examples in case study or example of daily life. So I may not discuss all protocols today. So I'm concentrating on about first about the Wi-Fi protocols, which is the most widely used one. Or I may go to the other protocols. So I'm going with the basic level protocols and the application level protocols. And little bit TCP/UDP protocols also, which are required for the understanding COAP and SMAP. So I am not covering all protocols today. Let's go to the only basics of the some protocols which are frequently used for IoT. So as we know, the very famous one is Wi-Fi. So what is Wi-Fi? Wi-Fi is a wireless technology enabling device to connect to the internet or local area LANs through wireless. Wi-Fi stands for wireless fidelity. It is common in IoT devices like smart home gadgets, wearables, and industrial sensors will communicate to the other devices through a Wi-Fi only. We have Bluetooth, we have Zigbee, we have Wi-Fi, but most widely used in today's trends is Wi-Fi. In Wi-Fi, we have three types or three protocols are there. But the role of Wi-Fi here is it has reliable, means it performs very well, it has very good strength, and it has very standard communication standards like 2.4 gigahertz speed. It can be used for both consumer and industrial applications. In our homes also, we can see a router also uses Wi-Fi network. Your mobile phone uses Wi-Fi network. Your TV also uses Wi-Fi network. So it is both consumer applications can be used as well as industrial IoT also. In the Wi-Fi, we have three protocols. The first one is multicast DNS. Multicast DNS. This will discover broadcast services information using multicast DNS on local network. Example, if I have a smart TV, you can see there is a Miracast tool. Miracast feature is there. That is nothing but mirror screening. The smart TVs have option called Miracast or screencasting, where whatever the content is there, my mobile phone can be played on my TV. You can see the picture here, where a person is able to share his laptop screen to the TV. So one example of multicast DNS protocol is mirror casting or screencasting. We have smart printers now. HP and other printers are able to communicate directly to the mobile phone. You can able to print directly also. You can see a picture here where the mobile is scanning the available networks. Mobile is scanning the available networks and found a printer. It is giving you direct print to the printer. Set-top boxes. wireless speakers. We have a wireless speaker for TV, which also can be used. Mu DNS devices. Nothing but multi-class DNS devices. Next one is the benefits of this one is zero configuration for local networks. So we don't need to configure again. Just I'll find just I scan my Wi-Fi network, the printer is available. Just I select the printer, I'll give a print option. So this also this multi-class DNS is also called as zero configuration protocol. It is very popular for home automation and smart TVs. The next one is Wi-Fi Direct for smart discovery. It is similar to the previous case, but has more speed compared to the previous one. Allows device connect directly to each other without a router also. Wi-Fi Direct directly without any router. If we go to the previous case, we may require a router in between. Now device automatically discover and establish peer-to-peer communication. In the previous example also, you can see this example is also example of Wi-Fi Direct. You can see there is no in-between router here. The mobile automatically scans the printer and prints the data. So device automatically discovers and establishes peer-to-peer means machine-to-machine communication. Peer-to-peer means from mobile phone to printer, there is a connection establishment. So one-to-one communication. Device automatically discovers and establishes peer-to-peer communication means a mobile phone and printer are communicating automatically. One more example, a sound bar is there, a smart sound bar is there, it's going to the TV. They are now peer-to-peer communication. Example, you can get file sharing between smartphones using share it option or data communication between IoT device like smart TVs and speakers. Now we can have a wireless speakers now, which can be played directly through a TV, or you can use a smart mobile phone to play your music to the smart speakers. The last one is universal plug and play. The universal plug and play, just plug the device, the mobile phone detect the device, turn on, turn off. So you can so without or minimal configuration. The universal plug and play is a protocol that allows devices to automatically discover and interact with each other on network. So example, I turn on the mobile phone, it did the smart bulb. When I click on smart bulb, I'll give operation to turn on the bulb. A simple thing. So plug and play devices. How it works? Device announces their services and capabilities. So when they connect to the smart bulb to the in my home, it automatically available into the available networks. And I can turn on the bulb automatically. Example, smart home devices like smart lights, cameras, thermostats can be used using universal plug and play, and they can work together also. Example, the smart mobile phone and a smart bulb can communicate with each other and make a device to on and off. What benefits we have using a Wi-Fi service discovery compared to the other service discoveries? The first benefit is no need of manual configuration, no need of manual configuration or user intervention. So most of the times we don't need to configure the things again. We don't need to set the IP address or we need to set the baud rates, all those things. And with minimum or without user intervention. Once they are configured, they don't need to again their intervention between the human being. There is no need of human being again involved in the perform the action. That is the first advantage. No need of manual configuration. Again, we don't need to configure manually. Once we connected directly, suppose once you configured your Wi-Fi router with your laptop, you turn on your laptop, it automatically connect to the Wi-Fi network. It's called no need of manual configuration or user intervention. So I'm not involved again to connect to the network. Second one, seamless integration. Different devices. Example, my laptop may connect to my board. My laptop may connect to my smart bulb or my TV. So different devices and manufacturer can connect and work together. If we have a Wi-Fi service is available, all different devices of different manufacturers can be able to communicate and work together. Example I told initially also, Alexa device able to turn on the Wipro smart bulb. Efficiency, as devices can dynamically discover services and optimize the network resources. So as I told initially also, efficiency is one of the advantage of this Wi-Fi network because they are dynamically discovered and they can optimize network resources means there are 10 networks available. For 12 there are 10 available. It will check all 10 networks. It will verify which has more strength and which has more speed, but latency. Signal strength and latency. So dynamically it will discover it connect to the network. COAP is one of the most widely used protocol of application layer for IoT operations. It is lightweight. Now, what do I mean by lightweight here? Means it requires less number of bits or it requires less number of encryption and decryption pins and bits. So lightweight means the payload will be of less weight. Payload means along with your encrypted data and original data. Example, we lightweight is UDP also. Designed for low power, low bandwidth. Low power means example Arduino board is operating at 3.3 volts. It's a low power device. Or a E32 is working on 3.3 volts. These are all low power devices. Low bandwidth. It operating at a low bandwidth. So lightweight, designed for low power and low bandwidth devices. COAP designed for lightweight means where data and where payload is as data plus encryption bits will have less number of bits compared to the TCP. TCP is more reliable compared to UDP, but it is lightweight. So how it works? It uses UDP instead of TCP for faster communication. Example, we are using now Zoom. Zoom is example of a UDP communication rather than TCP communication. Let us see what drawbacks we have for TCP, what advantage we have for. Generally for live streaming, we'll use UDP. Let us see in depth about what is TCP and UDP. These two UDP TCP are the transmission layer protocols. TCP, transmission control protocol. See, it is a one of the reliable protocol of transport layer where it is used in our web pages HTTP, in email program like SMTP and file transfers. It is the most widely used protocol of transmission layer. We have only two protocols in transmission layer. One is TCP, other is UDP. TCP is most widely used because of its advantages, like it is reliable. What is connection oriented? The first advantage what they are saying is connection oriented. What do you mean connection oriented? It doesn't mean that we have a valid connection here. Connection oriented means, as an example, like if I put a WhatsApp message to a person, how could I know he saw the message or not? First, we'll get a one tick means what? It went from your mobile to other mobile. Second tick indicates it went to the other end also. What is the blue tick indicates? He has read the message. That is called connection oriented. There is a authentication or a feedback for you or a acknowledgement for you that he had read the message. It's called connection oriented. So one more example. When I make a call to any person, the phone rings. When I make a call to the person, the phone rings. The ringing is indicates that the connection is established. It's a scenario whether he lift the call or not. If I get a message, if you don't lift the call, he disconnected your mobile connection or he is busy. So connection oriented means we'll get authentication from other end that the connection established to the other end. It is called connection oriented. Means from the sender to the receiver, we'll have a confirmation that the data is sent. It's called connection oriented here. Connection less means if I sent a mail, it will go to the other end, but I don't know whether it went to the person or not. I need to call him personally and ask him whether you got mail or not. So WhatsApp as a feature that we can able to see whether he watched the message or not, whether he read my message or not. It is called connection oriented network. Mobile phone connection also is a connection oriented where we will get a ring that the connection is established. Next, reliable transmission of packets in order. Reliable means I can believe on that. The data which is sending from sender to the receiver, they will reliable means we believe on that the data will go from other end to other end in a proper, safe way. So TCP reliable means we can trust on that communication device. Handshaking full duplex. What is handshaking mechanism? When I send the data to the other end, I'll get a signal that if you said yes, I am receiving data. That is called full duplex. Full duplex means example full duplex is mobile phone communication. When I call to the person, he also respond to me. Is a full duplex communication. Handshaking means there is a authentication from the other end that he is received data also. And it has some redirection and retransmission. When data is transferred from the sender to the from the TX to RX or sender to the receiver, if at all there is a data lost, it detects where is the data lost, it detects the error and it retransmits data again. That is available in the TCP protocol. There is a flow control and congestion control also. Flow control means is they are going in order or not. Congestion control means is there any traffic between, in between, is there any traffic between while it is transferred to the application layer. From transport layer, we send the transport layer to the application layer. If at all there is a traffic, it will make the sender to please wait for certain time. It's called flow control and congestion control. These are advantages of TCP. What the drawback we have? The drawback is as we have error detection and retransmission, flow control, congestion control. If we are going to implement all those things for reliable transmission, obviously it will be slow compared to the UDP. More overhead because the payload will have more encrypted bits. So we'll have more overhead is there because we are have to have a all these things to be followed. Next one is UDP. UDP is an alternate communication protocol to transmit to TCP. When we require this one, whenever I want to, my motto or my primary intention is low latency, means I want to send data at high speed. So I least bother about the send. Suppose I'm sending 10 bits or 10 packets. I least bother with let them go only 6 packets, but they will go it in time. So such cases we'll use UDP. Low latency means whenever we require high speed data transmission, we'll go for UDP. And loss tolerating connections means we can bear the loss of data also between the devices. In such case only UDP is preferred. So advantage is it transmit data at high speed. Drawback is we may lose data. We may lose data in between because in between we have any confirmation from the other end. In TCP, is a confirmation from the other end that I received data. In UDP, there is no confirmation from the other end. Advantages is connectionless. Connectionless means I no need to wait for the other end to give the acknowledgement. Fast transmission, as I told already, it has low latency. It can transmit data at high speed. Less overhead because we are not following any those parameters like error detection. It's optional. And flow control, congestion control, all these things are not there in the UDP. So less overhead because these are not there. What is the drawback over now? Less reliable because I can't relay because I can't ensure that complete data is sent to the other end. It's called less reliable. Optional error control. So here we have option to control error, whereas it is mandatory there. We have a error detection mechanism and retransmission also. Here we may not assure that we will transmit data again and again. No flow control because it is concentrating only about spending data at high speed. No congestion control, no traffic control, no flow control. This is the overview of difference between the TCP and UDP. The first one is connection oriented, whereas UDP is connectionless. And TCP is more reliable, whereas this one is less reliable. Here, Error control is mandatory, whereas here it is not mandatory. Here we, as these all are there, we'll have more overhead. It will take more time. So slow transmission. Here it will be fast transmission. TCP is more overhead because we have more payload, we have more encrypted bits, and we require authenticated bits also. Whereas here we usually bother about authentication, so it is less overhead. Here flow control is mandatory, congestion control also mandatory. Whereas this side they are not there actually. Only error control is also optional. You can see a picture which demonstrates the difference between TCP and UDP. You can see the picture here. The a person is making a call to the other person to make sure that he received data or not. You can see they are in ordered, then ordered, and they are seen to the other end also. Right? The other UDP, you can see some packets are missing here. You can see here some packets are missing, indicates the data is missing. And there is no acknowledgement. There is no acknowledgement from the other end. You can see one more diagram here. They are communicating. Here is only one-way communication. Now these are the application layer protocols: HTTP, COAP, WebSocket. And these are the most widely used ones. So we'll discuss very few of them like HTTP, COAP, WebSocket. Okay, let us have to only discuss about MQTT because which is the most widely used one. As we want to do hands-on also, I'll go for only MQTT protocol, which is very important protocol for IoT services. Yeah. Message queue telemetry transport protocol. It is a application layer protocol which is built on TCP. See here, message queue telemetry transport is a lightweight, means it also has less number of bits based on publish subscribe model. There are three communication models. It is built on publish subscribe model. Let us see, before going to about in depth about this, we'll see first what is publish subscribe model. I'll give example to understand what is publish subscribe model. Let us take a scenario where a client want to send data of temperature and humidity to the other end. There are three clients here: client 1, client 2, and client 3. Now in between there is a broker. Now this client 1 is sending data to the MQTT broker. This broker is asking anybody want temperature or humidity data. Now client 2 is asking I want only temperature, or client 2 want both. So client 4 may want both. So client 2 is asking only temperature. Client 3 is asking only humidity. The client 4 is asking both. Let us see here now it communicates. When I publish data, the client 1 published data, the broker received data and asked temperature and humidity both are available with me. Now the client 2 will get only for data what is subscribed. So he subscribed only for temperature, that only we will get. That temperature is nothing but a topic. And client 2 is subscribed for only humidity, you may get only humidity content. And client 4 as subscribed for both temperature and humidity, they'll get content of both. Just like in Netflix or Z or any paid OTT platform, for whatever you subscribe, you'll get the data. Similarly here also. Now here, the main thing is the broker is the mediator here, where the client 1, as a publisher and subscriber, will never communicate directly. So as I told already, it is the most widely used application protocol of IoT applications. It uses client server architecture where the TCP, where the client is IoT device connected to the server, also called as MQTT broker, and publishes message to the topics on the server. The broker forwards the message to the clients subscribed to the topics. The broker is the person who is a mediator sending data to the other end. And as I told you, there is no direct connection between the publisher and subscriber. It always through a broker only. There is no direct, you can see the diagram here once. You can see the diagram once. You can see here diagram once. The client 2, client 1, client 3, they are not connecting directly. They are connecting through a broker only. So always the data will pass from publisher to the server, a subscriber through a broker only. And as some quality services like QoS 0, which is fire and forget. There is no guaranteed delivery in the QoS 0. In QoS 1, it will deliver only once. Then delivery exactly at once. There are 3 QoS services are there. One is first I'll fire and forget and delete for the report whether received or not. Second one, I'll inform you that I'll send only once. Please get ready for that. Delivery at least once. At least once means I can send again and again. QoS 1. QoS 2 is delivery exactly once. You can send only once. COAP we discussed already. See here now in COAP the advantage is the clients can communicate. If compared to the MQTT, the clients one client 2 can communicate. You can see diagram here. You can see diagram here. There is a tab. There is a router. There is a bulb or a light. They are able to communicate internally. In COAP, clients can communicate, whereas in MQTT, the clients can't communicate. One more is AMQP, Advanced Message Queue Protocol. Where we have same like publishers and brokers and subscribers, but here we'll pair the subscriber and publisher with using a unique IDs. Let us come back to the service discovery in healthcare. What we have? We have medical devices like heart rate monitors, glucose, which we have seen in the previous classes, like heart rate monitors, glucose sensors, or wearable must discover each other to ensure synchronization. Suppose in a hospital, there is a devices like heart rate monitoring, glucose, and ECG monitoring. They should be synchronized to communicate and make the necessary actions. Protocols what can be used is a Zigbee, a Wi-Fi, or Bluetooth. For these, heart rate monitoring, smart device, or glucose sensors, or wearables, what we can to wearables which will sense the heart rate and SpO2. Survey discovered edge computing. What is edge computing actually? And how it is different from the normal cloud computing? Edge computing means analyzing the device data at the edge side or device side only. Suppose example, the drawback of cloud computing is if I am deploying a machine learning model and want to make an action in the cloud computing, the computing is done on the cloud. Again, the action has to come, the message has to come to the machine learning model or a device which is deployed to the machine learning model. If I use cloud computing and a machine learning deployed device, the computing is done in the cloud. Again, the signal comes from the cloud to make a necessary action. Example, I'll give example. I'm using a smart camera which is connected to the cloud. It will take the pictures and identifies the person and says, he is not an authenticated person. Please don't open a door or give alarm to the smart camera. Right? In this scenario, the data is going to the cloud. The cloud is computing it. Cloud is applying the algorithms and says that he is not an authentication person. Please do the necessary action. Whereas in edge computing, the device itself will take decision now. Device will only analyze data. So the device will have the mechanism to analyze data. That's called edge devices, which will analyze data. In the previous yesterday's session, we had explained predictive analytics, which is nothing but edge device as a capability to predict the things. Edge device process data closer to the source. Means A device has the capability to take decisions by analyzing the data. Benefits is it is faster than the traditional cloud computing. Reduces the latency means will perform or take the action immediately. Conserves less bandwidth as device is taking the things done by itself. It requires less bandwidth. You can see here. Service discovery edge devices. Service discovery can local services for quicker processing and response time. Service discovery in industrial IoT. Industrial IoT, we require a larger machines, a sensors and control system like PLDs to control the real-time data and optimize the industrial operations. And we turn off the device from a remote place by using various sensors. The protocol uses DDS. Similarly, we have service discovery in smart cities like traffic management, waste disposal. Similarly, we have the service discovery in automatic vehicles, like the vehicle will communicate with the traffic light and other things. Similarly, we have service discovery in wearables, where smartwatch and your fitness trackers will communicate using a Zigbee or Wi-Fi network. What challenges we have? Let us come to the what problems we have in the service discovery. The first is man in the middle. This is the one problem which will be there for service discovery of IoT. There may hacker will come into between when the data is transmitted between the one device to the other device through a internet or a cloud. So you can see a picture here. You can see a picture here where a person, actually the data should go in this way, but this is a person, man in the middle, is a hacker connecting directly and hacking the data of the devices. It's called man in the middle. Second one is spoofing. Spoofing means we'll get some malicious devices. We may get a message or a mail to open the mail. That's called spoofing. What is vegetation? They may encrypt or authenticate our devices without our intervention. Feature this service discovery in IoT is first is AI-driven discovery, where AI devices and algorithms may dynamically discover the devices and their usage patterns. Cross-domain IoT plus AI plus healthcare, IoT plus robotics plus AI is called cross-domain discovery. One more challenge, few more challenges, scalability, because as we are more number of devices connected to the network, we may get scalability issues. Device means we may have different type of device can be in single network operating different speeds. We may get some technical issues there. Security is already a reason for any cloud platform. Before starting to the, we'll have a once hands-on session. As I discussed about more about Wi-Fi today, we'll have a small hands-on session where the Wi-Fi will be where the USB32 will connect to the different available Wi-Fi networks. We'll take a small break and we'll verify how the my device S32 will discover the available Wi-Fi networks. Then we'll see one more Wi-Fi hands-on where we'll read the oxygen levels of a patient from a remote place. We'll take a short break now and we'll move to the hands-on session.
Participants, let us join for the hands-on session on today's topic.
Yeah, we are just doing a small hands-on session where the ES32 board, which is there here, we are discussing about this board from 2-3 days. It will scan the available all the Wi-Fi networks and displays the available networks in the output. Let us come to the code. First, a simple code is there here where we'll start with the void setup, serial.begin where this part will initialize the serial communication first to display the things on the serial monitor. Then we have a Wi-Fi mode, Wi-Fi start where the stationary mode, the station mode will be there enabled connect to the ES32 to the Wi-Fi available networks. Next, if they are not connecting, after this 1 minute it will disconnect. Previously, it was to disconnect after connecting to the available networks. Yeah, first it will be in state mode, connect to the different available Wi-Fi networks. To connect all the available networks, first of all, it should deconnect or it should disconnect from the present network. So it is disconnecting first from the present network, from disconnect from the any Wi-Fi network it may be previously connected to. Initially, if you see, by explaining the previous session, I told that it is connected to the KMIT underscore LAN. Now it will disconnect the KMIT LAN first. After that, it will again print that setup is done. It will start scanning now. It will start scanning and it will verify how many networks are available in the its range. See here, int n equal, it will show the number of available. It scans all the available nearby networks and returns the number of available also. Let us suppose I have 10, it will show all the 10. Next, it will, after scanning, message called scanning done. And if at all there is no network connected, if n equal to 0 means there is no any really available Wi-Fi network, it will display a message called no network is found. Else, otherwise, it will display the network found. This part will first CL print ln, where it will display the header line of network information like SSID, like what network name is there, like KMIT LAN or any other network names, KMIT ODI. You can see in the output now. And signal strength, what is the strength of the signal and how many channels it has, and the encryption type also. You can see the 4 columns here. One is the network name, its strength, its channels, and its encryption standard also. For that, it is this loop iterates and verifies available networks, names, RSS means signal strength, channels, and their encryption standard also. This is a simple switch case where it will verify all available networks and their encryption standards and display the if they are available in the network. Let me run the code once. You can see here. I'm going to the Arduino IDE. You can see here I'm uploading the code now. See here. Yeah. I'm uploading the code now. Let us see whether it detects the available networks or not. Yeah, it's sketching the file. It's compiling the sketch. Sketch is going on. It's compiled. It will take some time. Then it will connect to the available Wi-Fi networks. So in ES32, if you are using Arduino IDE, once compiling of sketch is over, you will get a message that connecting to the network. At that time, you have to press the boot button to dump the code into the device or ES32. There is a button called, you can see if let me zoom to the device, please. There are 2 buttons here. One is reset button, there is the boot button. Once I get a message called connected on the screen, you can see here, we'll get some message here like connected to the device. It's compiling the sketch now. Yeah, you can see the message here. It's basically message connecting. Then I should press the button. Then only it is able to write the code to the device. You can see a message called writing at 0.0002%, 5%, 8%. It goes on till 100%. So after uploading the code into the ES32, they're expecting the output as the available Wi-Fi networks should be shown on the CL monitor. It is 48% now. Let me wait until it comes become 100%. 77%. So once uploading is done only, you have to open the CL monitor. If you open the middle, you will get a CL monitor error. You can verify here. We got 100% now. You can see once we got writing at 0.00 and we got 100% here. Once you got 100%, you'll get a message called done uploading. Then you can go for tools, click on CL monitor. You can see the you can see here the scanner started. These are all readily available or available networks now. Every 1 minute is verifying the networks. KMIT LAN, KMIT block E, you can see KMIT ODI and its signal strength minus 40, 71, number of channels available. It is nothing but SSID, the network name, RSSI, channels, and its encryption standards. You can see here. Let me verify with my laptop also. Is all these are available with my laptop also. Let us check out once. In my laptop, also I can verify. You can see KMAT LAN is connected now, which is the first one which is showing there. KMAT audio which is also there, KMAT blocky. So my laptop is able to see only 3-4 networks. Whereas ES32 has longer range, which is able to show around 16 Wi-Fi networks. This is about today's session, where we are the basic one, which is the basic connectivity is required to perform any healthcare or IoT applications. We require connectivity first. So for this, we are using the basic protocol called Wi-Fi protocol, which will be the basic one to communicate with the IoT devices. To dump the code into IoT devices or to send data to the other end, we require a service discovery. One of them is Wi-Fi. Today we'll stop here today. If any queries are there, you can put in the message box. We'll share the code by the end of the session today. We'll share the code also for your practice. Thank you.
So if you have no questions, then I think we'll ask Anil sir to stop sharing. Thank you, Anil sir, for a wonderful session.
Thank you, sir.
A big thank you to Anil sir for his insightful session on service discovery in IoT. His expertise and deep understanding of the topic has provided us with valuable knowledge on how IoT devices efficiently discover and communicate with services, ensuring seamless interoperability in smart systems. Key takeaways from his session include what is service discovery, benefits of it, types of service discovery, how it actually works in IoT, various protocols used in IoT, and future of service discovery in IoT. We truly appreciate your time and expertise, sir. Thank you very much. I would request the participants to wait for a couple of minutes. The next session will start in a minute. Now, moving on to our next session, we are honored to have with us Mr. Y. Madhusudan, sir, a highly accomplished professional with over 20 years of experience in software development. He holds a BTech in Electronics and Instrumentation from KITS Warangal and an MTech in Computer Science from IIT Kanpur. After completing his MTech, he worked at Mentor Graphics for 3 years before moving to the United States of America, where he has been contributing significantly to the software industry. Currently, he is working as a software engineer and mathematician at U1 Gaming, USA. His expertise lies in developing embedded softwares for slot machines and designing mathematics for slot games, showcasing his deep understanding of both software engineering and applied mathematics. In addition, he has published research papers in reputed international journals, further establishing his contribution to the field. Today, he will be speaking on research topics in IoT and smart cities, an area of immense importance as we move towards smarter, more connected urban environments. His session will shed light on the latest research challenges, innovations, and opportunities in IoT applications for smart city infrastructure, making this a valuable learning experience for all of us. We welcome you, Madhu sir, as for the exciting session.
Thank you for welcoming me. Well, my name is Madhusudan. I'm gonna do a small presentation on IoT in healthcare. Okay, let's start with, for today, for today's agenda, I'll give you an overview of IoT, and then we'll look into the healthcare examples of IoT, and then we will see what technologies are used in IoT healthcare, and then we will look into the challenges in IoT healthcare, and we'll see what are the latest research topics in IoT healthcare. Okay, let's get started. So what is IoT? IoT is the Internet of Things. It refers to a network of physical devices, vehicles, appliances, and other physical objects that are embedded with sensors, software, and network connectivity, allowing them to connect and share data. IoT devices are also known as smart objects, can range from simple home devices like smart thermostats to wearables like smart watches and RFID-enabled clothing to complex industrial machinery and transportation systems. Technologists are even envisioning entire smart cities predicated on IoT technologies. So IoT enables these smart devices to communicate with each other and with other internet-enabled devices like smartphones and gateways, creating a vast network of interconnected devices that can exchange data and perform various tasks autonomously. This can include like monitoring environmental conditions in farms, managing traffic patterns with smart cars and other automotive devices, controlling machines and processes in factories, tracking inventory and shipments in warehouses. And the potential applications of IoT are vast and varied, and its impact is already being felt across a wide range of industries, including manufacturing, transportation, healthcare, and agriculture. As the number of internet connected devices continues to grow, IoT is likely to play an increasingly important role in shaping our world, transforming the way that we live, work, and interact with each other. So why should we use IoT? What are the benefits of IoT? So IoT improves efficiency. So by using IoT devices to automate and optimize processes, businesses can improve efficiency and productivity. For example, IoT sensors can be used to monitor equipment performance and detect or even resolve potential issues before they cause downtime, reducing maintenance costs and improving uptime. It also helps us make decision making using the data. So it's helpful in data-driven decision making. IoT devices generate vast amounts of data that can be used to make better informed business decisions and new business models. By analyzing this data, businesses can gain insights into customer behavior, market trends, and operational performance, allowing them to make more informed decisions about strategy, product development, and resource allocation. And IoT also helps us to cut the costs. By reducing manual processes and automating repetitive tasks, IoT can help businesses reduce costs and improve profitability. For example, IoT devices can be used to monitor energy usage and optimize consumption, reducing energy costs and improving sustainability. Enhance customer experience. By using IoT technology to gather data about customer behavior, businesses can create more personalized and engaging experiences for their customers. For example, retailers can use IoT sensors to track customer movements in stores and deliver personalized offers based on their behavior. Let's look into what makes an IoT. What are the elements of IoT? So the backbone of IoT are the sensors and the actuators. Sensing is the gathering of information from all devices. Sensing is the gathering of information from all devices within the IoT and then transmitting that information to any data warehouse or cloud for further processing. To accomplish more benefits from the IoT, smart actuators and sensing devices are required. All devices are connected to a central management service to offer the data required by the customer. In healthcare services, the important objectives of the sensors are to regulate, monitor, control, warn, and track the activities of the patient. So now we have got the sensors. Now these sensors need to communicate. So the next important IoT element is the communications. In IoT, the communications between heterogeneous objects is possible through different communication protocols, such as near-field communication, Wi-Fi, RFID, the radio frequency identification, ultra-wide bandwidth, Bluetooth, LTE, and etc. And we also need the processing capability for the computations. So IoTs use a range of processing units like microprocessor, microcontroller, field programmable gateway array systems on a chip. They also use various platforms like Raspberry Pi, T-Mode, Sky, and more than the hardware and the processors is the software, like software platforms like cloud and big data. And of all these software platforms, operating system is the most important. IoTs use various operating systems, and the real-time operating systems are widely used for the development of IoT-based applications. The IoT provides a wide platform. The cloud provides a wide platform, and it is a key part of the IoT. The role of the platform is to facilitate the smart devices to transmit the information to the cloud for real-time processing through big data. As a result, the user receives information that is extracted from the big data. And the next IoT element is the service element, the services. The services represent a set of end-to-end services in which businesses contract with external providers to design, build, install, and operate IoT solutions. The IoT services are categorized into identity-related, ubiquitous, collaborative aware, and information aggregation services. Identity-related services are the basic services that are very useful in functionalities of the other devices. All the applications that want to show real-world objects in the virtual world have to identify such objects. The information aggregation services gather, process, and report the collected sensor information to IoT applications. Collaborative aware services make decisions and react accordingly on the information of aggregation related services. Ubiquitous services are the services provider to the collaborative aware services and hence can provide services to any or at any location. So let's see how an IoT network looks like. So this is how the IoT network looks like. In the middle, we have the IoT server. That is the core part of the IoT. At the bottom are the sensors. These sensors communicate with the server through IoT gateways and smartphones or any other networks like Wi-Fi, Bluetooth, Z-Wave, etc. And then the IoT server, it collects the data and communicates with the actual IoT application on the top level. For example, the structural health, the environmental monitoring, e-health monitoring, traffic monitoring, and smart home. So basically, this is how IoT network looks like. Let's look into some of the examples for IoT in general. So I'll give you some practical examples from the industry right now. We'll look into LG's ThinQ appliances. LG's ThinQ line of appliances incorporates machine learning and can easily connect to Google Assistant and Amazon's Alexa. LG's ThinQ application can also be used to connect to devices, and these devices will notify you when maintenance is needed. Users can choose from smart appliances like refrigerators, washers, dryers, and ovens. Next application is the Wisey's smart security. So Wisey, a wide range of IoT control devices and appliances to help people control. Wisey makes a wide range of IoT control devices and appliances to help people control the products they interact with more seamlessly. The smart security cameras offer both wired and wireless options and can be stacked on top of each other to provide more coverage. The app can connect to any of the company's devices so users can view video feeds when they are away from their home. And the next one is a John Deere precision farming equipment. Farming equipment monitors important agricultural factors like moisture levels, air and soil temperatures, and wind speed, and relays the collected data to farmers. The company's tractors and other equipment are outfitted with satellite-connected guidance and tracking systems that collect data, allowing for what's called precision farming, which greatly increases the efficiency of fertilizers and pesticides. The next technology we're looking into is the checkout-free technology. Remember how we stand in the lines to check out? Now, with the help of this checkout-free technology, we don't have to do that anymore. It employs an ecosystem of sensors, cameras, and check-in kiosks to support checkout-free retail stores. The shoppers check in with an app or credit card at a kiosk before entering the store. Then sensors and cameras track when shoppers select items off of shelves to determine the total charge. Customers can view their items and automatic charges on their phones without having to wait in a checkout line, creating a more seamless in-store experience. So we don't have to even wait in the line. The next is the Telit Smart Lighting System. Telit builds IoT connectivity management platforms that can be scaled up to sustain the needs of smart cities. With these platforms, cities can use mobile devices to monitor public lighting, dim or brighten them based on the time of the day and traffic needs, and stay on top of any lighting outages. City governments can also adjust lights in different areas to accommodate first responders and deter crime for certain hours, among other use cases. So the last one we're going to look at is the House Alerts Safety Cloud. House Alert has designed a safety cloud for first responders and other emergency personnel to communicate alerts with drivers in real time. Drivers can receive digital alerts about upcoming accident scenes, approaching emergency vehicles, and students crossing the street up ahead to board a school bus. Giving drivers a fast heads up in these scenarios allows them to take extra precautions, preventing additional accidents and traffic confusion. Okay, let's look into. So far, we have looked into the general IoT applications. Now, let's dig deep into the healthcare. And let's look into some projects that are used in IoT healthcare. So, the first one we're going to talk is a smart inhaler. Smart inhalers mark a significant advancement in IoT healthcare projects. They equip regular inhalers with technology to observe medication usage and send this data to mobile application. This unique approach empowers patients, particularly those with asthma or chronic obstructive pulmonary disease, to substantially improve their treatment management. The use cases are medication tracking, provides adherence data, informing providers about patients' medication schedules. And it also sends medication reminders to patients, reducing missed doses. The next is remote patient monitoring. Remote patient monitoring is an innovative application of IoT in healthcare projects is transforming home care delivery. Utilizing IoT-enabled devices allows patient health metrics to be monitored without needing the patient to stay in a hospital, a step forward from customary healthcare approaches. The use cases are chronic disease management, collects patient data for real-time disease management and treatment. Post-discharge care. It helps monitor post-discharge health for smooth recovery. The next one is connected contact lenses. The connected contact lenses showcase an innovative application of IoT in healthcare projects. Integrated with IoT technology, connected contact lenses can measure glucose levels in diabetic patients through their tears. This approach is set to go past traditional glucose monitoring methods by eliminating blood pricks, providing a more streamlined monitoring process. So the use cases are glucose monitoring, non-invasive monitoring of glucose levels in diabetic patients, and it sounds on an alert system. It sends alerts when glucose levels deviate from the normal range. The next application or project is the smart beds. The continuous progression of IoT healthcare projects brings forth smart beds. These beds, equipped with sensors, continuously monitor the patient's vital signs and sleeping patterns, offering enhanced patient care. Optimal comfort delivered by the smart bed and the insightful data it provides makes it a significant player in patient care. So it helps in vital signs monitoring. Sensors in the bed track heart rate, blood pressure, oxygen levels, and other vitals continuously. It also helps sleep pattern analysis, monitors and records sleep patterns to diagnose sleep disorders. I think everybody knows about these. These are the wearable fitness devices like smartwatches. The wearable fitness devices are the prolific healthcare projects where IoT has been exceedingly impactful. Primarily used to monitor health metrics like heart rate, step counts, and sleep times. These wearable devices have been instrumental in encouraging proactive health and fitness management among individuals. The use cases are personal health monitoring and data sharing with providers. In personal health monitoring, the smartwatches, they track heart rate, calories, steps, and sleep for health management. And they also send data to healthcare providers for better health management. The next are the smart wheelchairs. IoT in healthcare projects has transformed assistive technology too, with smart wheelchairs serving as an excellent example. These IoT-powered wheelchairs often increase independence to users with mobility impairments. The chairs can monitor users' health data and navigate autonomously using sensors and artificial intelligence. So the use cases are health monitoring. The smart wheelchair track vital vitals and alerts providers in emergencies, and it does automatic autonomous navigation. The smart wheelchairs, they use sensors and AI for independent navigation. Smart prosthetics, expanding the reach of IoT in healthcare. Smart prosthetics are changing lives. These IoT enabled prosthetics offer enhanced functionality and adaptability, improving the user experience. Each movement and adjustment is made smoother, marking a significant advancement from traditional prosthetic devices. The use cases are adaptive adjustments. Smart prosthetics adjust grip and positioning for smooth movement. The next is the user data collection. The smart prosthetics collect data to personalize and optimize user experience. So this is an important IoT healthcare project. It is called Automated Insulin Delivery System. Taking a better route in diabetic care, automatic insulin delivery systems are one of the considerations in IoT healthcare projects. These systems continuously monitor blood glucose levels and automatically deliver the required insulin dose, simplifying diabetes management. The use cases are continuous glucose monitoring. So these devices, they track blood sugar levels in real time, and they also deliver insulin based on blood sugar levels, reducing errors. Smart pill bottles. The smart pill bottles, this is yet another innovative application of IoT in healthcare, ensure medication adherence. So equipped with light, sound, and text alerts, they remind patients to take their medications on time, making them particularly valuable for patients with critical or long-term medication needs. So they send medical reminders. They alert patients when it's time for their next dose. And they also help to see if the patient is following medication adherence. It monitors bottle openings and alerts providers if doses are missed. So this is important for old age people, the fall detection devices. So fall detection devices stand as a noteworthy contribution to IoT healthcare projects. These devices, mainly worn as pendants or watches, automatically alert family members or healthcare providers if a fall is detected. They're particularly valuable for elderly care, ensuring immediate medical attention when necessary. The use cases are fall alerts, detects falls and sends alerts to contacts. And it also provides the location of the patient. So it uses GPS location tracking, provides location for quick medical attention assistance after a fall. And the next one is very important. It's called smart pacemaker. The smart pacemakers are a leap in IoT healthcare projects. These advanced versions of traditional pacemakers are capable of real-time activity recording. By transmitting this data to healthcare providers, any potential heart irregularities can be addressed promptly, thereby elevating cardiac care. So the use cases are heart activity tracking and alert system. So it records heart rhythms and sends real-time data to the providers. It notifies providers of abnormal rhythms or malfunctions for quick response. Okay, having looked at the examples, let's look into what are the smart technologies that are used in IoT healthcare. So what technologies make it possible? So the first one are the smartphones. Everybody has a smartphone these days. The smartphone plays a vital role along with IoT in healthcare systems. So smartphone acts as a gateway between the sensors and the IoT application. It uploads the collected data to the servers in real time. Physicians and healthcare providers can check this data in real time. Smartphones instantly alert the patient and healthcare providers when action is needed. So the other technologies are the wearable technologies that we already looked into. So wearable devices are electronic devices that are worn on the body that collect and transmit health data like heart rate, blood pressure, blood glucose levels, or activity levels, using internet connectivity to send this information to healthcare providers or a patient's app for monitoring and management, allowing for real-time insights into health conditions and potential early detection of issues. Wearable devices include smartwatches, wristbands and patches, face masks, smart lenses, smart textiles, teeth sensors, microneedle patches, and electronic tattoos. And the next technology that are used in IoT healthcare are the ingestible sensors. So these are like they look like pills with sensors. When patients take them like a pill, they collect data from inside the body. So the next technology that are used is the smart robots. Smart robots. Robots are used to collect and drop the infectious items of the patients into the trash, move objects of the patients from one place to another place around the hospital, clean the hospitals, disinfect the patient rooms. Germ zapping robots use ultraviolet light to do automatic cleaning and can continue proactively cleaning around the clock. IoT enabled surgical robots can help surgeons perform complex procedures with greater precision. Artificial intelligence and machine learning provide the capability to process, analyze, and derive meaningful insights from the collected data. AI algorithms can analyze medical images with precision, helping radiologists identify abnormalities. With predictive analytics, AI can forecast potential health risks, enabling easy early interventions. By integrating patient data from various sources, AI can also aid in devising personalized treatment plans, ensuring each patient receives care tailored to their unique needs. Communications technology. The communications technology assures connectivity between different devices in the healthcare environment. Communication technology is further classified into short, medium, and long range communications. Short range communications are used for a limited area, especially for body area networks. Medium range communication is used to interconnect devices at a large distance, such as communication through Wi Fi between a server and a central node of the band. Long range communication is used for more considerable distances compared to medium range communication, such as satellite communication. The global positioning system is widely used technology for tracking purposes. The next is called ambient intelligence. Ambient intelligence is the concept of capturing and processing data through sensors, processors, and actuators unobtrusively embedded throughout the environment. So the patient don't even realize that there are sensors collecting their data. These ambient systems provide connected, seamless, uninterrupted everyday experiences that require no human intervention and react autonomously. Augmented reality is an interactive experience that enhances the real world with computer generated perceptual information. AR is used to guide medical experts in medical training and education, remote monitoring, and surgery. So, having looked at the smart technologies used in IoT healthcare, let's look what are the challenges in IoT healthcare. As usual in any computer related fields and information technology, privacy and security is a big challenge. The IoT operates in a heterogeneous network, and the primary responsibility of the IoT is the exchange of information between devices and different internet connections. So therefore, it's a challenging to assure the privacy and security of every device and connection. The data are transferred from many sensors, devices, and network connections, and hence are very vulnerable. To protect the information of the user on a cloud-based IoT platform, secure authentication mechanism along with the communication control and access control model are required. Other issues in security are the physical security, the safe data storage, data encryption, and secure routing protocols. Again, as with any other information technology product, performance and reliability are very important, especially for healthcare, because we don't want any medical device to stop abruptly. So performance here refers to how effectively an IoT device collects, transmits, and analyzes patient data. Reliability indicates the consistency and dependability on the device to function accurately without failures. So many parameters used to evaluate performance, such as processing speed, cost, packet loss, response time, availability of the services, speed of the communication services, delay, throughput, etc. The next challenge is interoperability. IoT uses several devices, sensors, and they use different protocols, and everything is heterogeneous. To operate these different heterogeneous devices from other platforms is a very challenging task. So the issues in interoperability include development of universal standards for interoperability in healthcare IoT and seamless integration of devices across different healthcare sectors. The next challenge is implementation. Smart communities need millions of low cost, low power sensors and devices. It is not easy to maintain, implement, and update such an extensive and intelligent infrastructure. Fault tolerance and resistance are the two main important challenges for reliable data delivery between sensors and embedded devices. Another critical challenge is the cost of devices used in communication, operation, and infrastructure. The next challenge are the standard operating procedures for devices. IoT devices are made of semiconductors and can cause more complications if implemented on the human body. Therefore, care must be considered and guidelines are required during device manufacturing. The radio spectrum should be within safe zone of data communication because too many devices and radio frequencies can negatively impact human health, animals, and even the entire ecosystem. Therefore, guidelines should be followed properly during the manufacturing and implementation of the devices. The next is the integration. IoT uses results from many research areas such as medicine, hardware engineering, software engineering. IoT healthcare encompasses many technologies such as artificial intelligence, networking, hardware, sensors, computing devices, cloud computing, big data, and many more. So it's a big challenge to integrate various technologies into IoT healthcare. The other issues I'm just going to cover them briefly. So these are the e-management of sensors and devices. It's a challenge to manage, configure, and use a vast number of devices. The quality of service in terms of reliability, efficiency, and service level is essential in healthcare systems and should not be compromised. The regulatory and legal framework. The regulatory landscape for IoT in healthcare is complex and differs across countries. So it's a big challenge for the manufacturers. Finally, let's look into the research topics in IoT healthcare. So IoT enabled remote patient monitoring. The research focus in this is on the development of low power, high precision sensors. One of the challenges in remote patient monitoring is ensuring continuous and accurate data collection while minimizing power consumption. Research in low power sensors, which can track various health parameters such as heart rate, blood pressure, glucose, and oxygen saturation, is crucial. The next focus is on the predictive analysis in RPM. Using machine learning and AI to predict acute events or worsening conditions based on continuous patient data. Long range connectivity. Research into low power wide area networks, LPWANs, like LoRaWAN and NB-IoT, to enable reliable data transmission over long distances, especially in rural and remote areas. So the impact. What is the impact of this research? The remote monitoring could help in early disease detection, reduce hospital admissions, and improve chronic disease management. The next is IoT for chronic disease management. The research focus is on these topics: personalized monitoring systems, multi-parameter integration, and patient behavior analytics. Development of personalized IoT solutions tailored to the needs of individuals with chronic diseases like diabetes, hypertension, and asthma. Research can include integrating data from wearables, sensors, and other IoT devices to offer more customized healthcare plans. Research on combining multiple health parameters, for example, ECG, glucose, blood pressure, into a unified system, improving diagnostic accuracy and offering holistic patient care. Developing AI algorithms to analyze lifestyle data and predict health deterioration based on lifestyle choices and habits. The impact: chronic disease patients would benefit from continuous monitoring, enabling proactive healthcare and reducing complications. The next area of research is AI and machine learning for IoT healthcare. The research focus is on AI-based support systems. IoT systems generate vast amounts of data. The next frontier is healthcare is to leverage AI to analyze this data and provide real-time decision support for healthcare professionals, including diagnostic recommendations and treatment plans. Predictive analysis and early diagnosis. Research into using AI and machine learning to analyze IoT data from patients to predict and diagnose diseases early, such as heart diseases, cancer, and neurological conditions. Deep learning for signal processing. Using deep learning models to enhance the interpretation of signals from IoT devices, such as ECG and EEG, offering more accurate assessment of patient health. The impact: AI and ML in healthcare IoT could revolutionize clinical decision making and improve the speed and accuracy of diagnostics. The next research area is wearable devices and sensor technology. So the research focus is on development of non-invasive wearables. The need for non-invasive, that means we don't have to use needles and stuff. So the need for non-invasive, accurate wearable devices for continuous health monitoring is growing. Research can focus on the development of advanced sensors that can monitor complex health parameters like blood glucose, hydration levels, and oxygen saturation without the need of needles or invasive procedures. Integration of multiple sensors. So there's a lot of research going into the integration of various sensors, such as accelerometers, gyroscopes, and biosensors into one compact, comfortable, wearable device to monitor a broad range of health metrics. Biomarker detection. Developing wearables that can detect biomarkers in sweat, breath, or skin to monitor specific diseases like diabetes and respiratory conditions. So this research area has a wide impact. Wearables can enable continuous, non-invasive health monitoring, reducing the need for hospital visits and allowing patients to be more proactive about their health. So the next topic is edge computing and healthcare IoT. So edge computing is like local computing, data processing at the edge. With IoT devices generating vast amount of data, it is critical to process this data locally or at the edge to reduce latency, improve real-time decision making, and reduce bandwidth requirements. Research in edge computing focuses on low power, resource efficient edge devices that can handle medical data processing in real time. Integration with cloud. So developing hybrid systems where edge devices process time-sensitive data locally, while non-critical data is sent to the cloud for long-term storage and analysis. Security and privacy in edge IoT systems. Since healthcare data is highly sensitive, edge computing research also involves developing secure and privacy-preserving techniques for handling patient data. The impact: edge computing can enable faster decision making and ensure that healthcare systems operate efficiently, even in bandwidth constrained or remote environments. Smart hospitals. So the research focus is on real-time location systems. So research on real-time location systems for asset tracking, patient tracking, and staff coordination within hospitals. IoT-enabled systems can track the location of medical equipment like infusion pumps, wheelchairs, to reduce operational inefficiencies. Environmental monitoring. Developing IoT sensors to monitor hospital environments for factors like temperature, humidity, and air quality, which can affect patient health. We also talked about smart robots. So smart robots also help in maintaining hospitals. So interoperability in smart healthcare systems. Research on creating interoperable IoT solutions within healthcare environments that work seamlessly with existing electronic healthcare records, systems, and medical devices. The impact: the smart health hospitals would enhance operational efficiency, improve patient safety, and help healthcare providers make data-driven decisions in real time. IoT integrated pharmacogenomics and personalized medicine. So the research focus is on genomics data integration, pharmacogenomics and drug interaction, personalized drug delivery systems. So the research into integrating IoT healthcare health data with genomics data, for example, genetic testing, personalized treatment plans. The use of wearable devices to monitor a patient's health while integrating genetic information can offer highly tailored treatments. The research on how IoT devices can help detect adverse drug reactions and identify potential drug interactions based on real-time patient data and genetic markers. The development of IoT-enabled devices that can deliver medication to patients based on real-time health data and genetic predispositions. This research will enable personalized target treatments and medication regimens, improving treatment efficacy and reducing adverse effects. And the last topic of research we're considering today is the IoT for mental health monitoring. The research focus is on wearables for mental health. Research on wearable IoT devices that can monitor health indicators such as stress levels, mood changes, and sleep patterns. This could be especially useful for tracking conditions like depression, anxiety, or PTSD. The other area of research focus is predictive mental health analytics. Developing IoT systems that analyze behavioral data, for example, activity levels, speech patterns, to predict mental health episodes and provide early interventions. Integration with therapy and counseling. Research into integrating IoT data with telemedicine and virtual therapy platforms to provide real-time support to patients suffering from mental health conditions. Impact. The IoT in mental health can enable early intervention and improve the effectiveness of therapy by providing continuous monitoring and real-time feedback. Thank you. That's all I have got for you. Any questions?
Thank you, sir. Participants, do you have any questions? I guess there are no questions, sir. Uh,
Okay. Thank you. Thank you
uh,
very much for giving me
a
this opportunity.
heartfelt thank you to you, sir, for this engaging and insightful session on research topics in IoT and smart cities. Your
You're welcome.
expertise and deep knowledge have given us a valuable understanding of the emerging trends and challenges in this field. And some key takeaways from your sessions include the role of IoT in building smart city infrastructures, IoT elements like sensing, communication, services, etc. And we also saw how IoT networks looks like and general IoT examples and the impact of AI and data analytics in optimizing urban planning and the challenges of security and scalability in smart systems and edge computing in healthcare IoT. Your insights have truly broadened our perspective on how IoT is shaping the future of smart cities. Thank you very much, sir, for your time.
You're welcome. Thank you.
I would like to thank all the participants. And we have seen the introduction to IoT in medical applications, and we have also seen the research areas. We had hands-on sessions on the IoT, and we have seen sensors, accumulators, intelligent D2D communications, and applications of IoT in medical field. And we saw data management and big data analytics in IoT. In today's session, we have seen research in IoT field, and we have also seen service discovery in IoT. I would like all the participants to thank, and I would like to inform you that tomorrow's session will start at 2 o'clock instead of 6. I repeat, tomorrow's session will start at 2 o'clock instead of 6 o'clock.
Okay, ma'am.
Thank you all. Good night.
Good night,
And
ma'am.
please submit the feedback before leaving. Thank you.